this chemistry video. Now here we're looking at the topic of titrations. So let's dive in and have a look and see what we mean by the term titration. Well, a titration, as a good question asked, is the following. Okay, a titration is a technique where a solution of known concentration is used to determine the concentration of an unknown solution. So say for example we have an acid of known concentration, we can titrate it with an alkali to find out the concentration of the alkali. A few terms here we're using. Let's just see what we mean by these. So let's think about concentration now. Molarity, you may have come across this before, is the concentration of solution expressed as the number of moles of the solid dissolved in 1 litre of solution. That may sound a bit of a mouthful. Let's go back through it again. So molarity is the concentration of a solution expressed as the number of moles of solute or solid dissolved in 1 litre of solution. What's this about moles, I wonder? Now, we can have a think now about moles. Now, you may have come across this before. 1 mole of a compound is the relative molecular mass expressed in grams. For example, relative molecular mass of sodium hydroxide, NaOH, there it is there, is in fact 40. And all we do is we add the mass numbers together. So sodium 23, oxygen 16, and hydrogen is 1. Now where do these numbers come from? We'll look at your periodic table. Say we look at the sodium, there's Na, sodium. You'll see 2 numbers, there's 23 there and 11. These are on your periodic table. Now this one here, the bigger number, is the mass number, and that's the one we use. So we have the mass number of sodium, add it to the mass number of oxygen, the mass number of hydrogen, and we get the figure here of 40. Okay? So we can say that all you do is put the G, the grams, behind it. 1 mole of sodium hydroxide weighs 40 grams. That's all there is to it. Very easy. So we want a molar solution, we just dissolve 40 grams in 1 litre, and that gives us a molar solution. Let's look at some examples of that. So we know that 1 molar solution is 40 grams in 1 litre. So it makes sense, you've got 2 molar, you're simply doubling it, so it's 80 grams. And if you want 0.5 molar, okay, you're simply halving it, 20 grams. So have a go yourself now. What would be a 0.1 molar solution? How much solid would you dissolve? So stop the video, have a think. Well, I hope you got it. The correct answer is 4 grams. So think, if 1 molar is 40 grams, it stands to reason that 4 grams is 0.1 molar. Okay, so 0.1 is 4 because 1 is 40. That's all it is, dissolved in 1 litre of solution. Anyway, let's get back to titration. Here's a typical equation for an acid-alkali neutralization reaction. Here's the acid, in this case hydrochloric. Here's the alkali. Now sometimes in some books you'll see it refers to as a base. Okay, some books refer to it as a base, other books refer to it as an alkali. Now the only difference between these two is that an alkali is a soluble base. That's all there is. So we've got the 4 common alkalis are sodium hydroxide, potassium hydroxide, calcium hydroxide, and ammonium hydroxide. Okay, so if you see these 2 terms here, don't get confused by them. Okay. What else do we know? Well, here's the equation. You always need to have the equation. Here's the equation, balanced. Okay, we know the concentration of the acid is 0.1 molar. Okay, we're given that. You've got to be given one of them. What we don't know is the concentration of the sodium hydroxide. I'm not going to go through the detail of the titration, but here it is. Use pipette to transfer 25, so we know we're going to be adding 25 cc's of sodium hydroxide into a conical flask. Then add your indicator. Now you may know your indicators. You may know if we use litmus. Litmus is blue in alkali, but when it becomes acidic it becomes red. So red in acid. Now how do you remember these two? Very simply, look at this. You've got D in acid and a D in red, and an L in alkali and an L in blue. Very easy there to remember, isn't it? Then we fill the burette to 0 with our acid, then we add the acid until it goes from blue to red. Okay, and we record the volume of acid needed. Let's look at what happened. Well, we found by titration we added 20 cubic centimeters of acid to exactly neutralize 25 cc's of alkali. And look at the equation. This is the key thing. Now, 1 mole, imagine there's a 1 there, of acid reacts with 1 mole of sodium hydroxide. Okay, we'll come across this with another example in a few moments. Just bear that in mind, though. Okay. Now, this is the equation we need. Molarity of alkali. This is what we don't know here. Equals the titration that we do know, which is here, times the molarity of acid we know, which is here, divided by volume of alkali we know, which is here. So we've got everything we need to work out the molarity of alkali. So here we are. All we do, we put the figures in. Now, some books, some places, they'll convert this into litres. So 20 cubic centimetres would be 0.02 litres. Okay, and they might convert that into litres as well, and that would be 0.025 litres. But for our example here, we're leaving everything in cubic centimetres. Okay, doesn't make a difference. And 0.1, we know where that comes from, and the answer is 0.08. So 0.1 molar acid, 20 cc's, neutralizes 25 cc's of 0.08 molar alkali. Right, let's look at another example. Now this one here, we've got slightly different in that, look at what's in front. We've got 1 mole of that reacts with 2 moles of that, and there we have it. Okay, so we're going to have one more down. There we go. So 1 mole of the acid there reacts with 2 moles of the alkali there. What else do we know? We know this is 0.2 molar. We're given that. The titration has been done. We know that we needed 22 cubic centimeters of that. We don't know the concentration there, but we do know we used 25 cc's. We pipetted that in the conical flask. We know that. Let's look at the equation. Okay, so molarity of alkali, which we don't know. Do we? Nope. Now 2, your 2 goes there. Why is it 2? Well, because we've got 2 of these reacting with 1 of those. Okay, so 2 goes there. The titration we know, there. Molarity of acid we know, which is there. So volume of alkali we know, which is there. And put those all in, and we get this. We find molarity of alkali 2 times 22 times 0.2 divided by 25, and the answer is 0.352 molar. So we now know the concentration of our alkali based on that equation. Okay, let's look at an exam question. Oh, sorry, I forgot to add this. This is little, just to remind you, always remember this: volume of acid equals molarity of acid. Sorry, volume of acid times molarity of acid is volume of alkali times molarity of alkali. Don't forget numbers like these here to include those as well if need be. Okay, remember what we did here? Okay, we put the 2, didn't we? We put the 2 in front there. Let's look at an example. Here's a past paper, and this paper here, we're told the equation for the formation of ammonium nitrate, which is this one here, okay, is given here. Now from ammonia, this is ammonia solution. Okay, now be very careful. This isn't in fact right out in full. This is ammonia solution, NH4OH. Okay, this is an alkali. This is ammonia solution. Sometimes you're given that form there. Give it a complete equation. If we're using that, we should put here H2O liquid. Okay, that's the complete equation there for neutralization. We're told 25 cc's of the ammonia solution, okay, of concentration 0.3 molar, were reacted with a solution of nitric acid. Now we're told 15 cc's of the acid were required to exactly neutralize it. Calculate the concentration of the acid. So let's see what the equation should tell us. Now what do we got? Volume of acid, we have got that because it's there. Molarity of acid, no, we're asked to find that. Volume of alkali, we've got that, that is there. Molarity of alkali, we've got that, and that is there. So we need to rearrange the equation now. Here's the rearranged equation. We don't know that. We know the volume, we know molarity, we know that volume there. Let's put the figures in. What do we got? We've got molarity of acid is 25, okay, which we know is from there, times 0.3 we know is there, 15 we know is there. Work those out, you get the answer of 0.5. So the concentration of the nitric acid, the answer is 0.5 molar. Okay, well that's the end of this video. Hope it helps, and I'll be back with you again very soon. So bye bye for now.